ESP32s are such nice microcontrollers, but not this one. Today we will build a rubber ducky or bad USB, a device that looks like a USB stick but acts like a keyboard to hijack any computer it is plugged into. No programming skills are required. Just buy an ESP32 S2 board and flash it with the online tool. There are two ways to build this. The first option is the easiest. Just buy a standard ESP32 S2 board like this ESP32 S2 Mini and plug it in. No soldering, just flash and go. The second option, the Pro Custom PCB for the makers. I have designed a custom ESP32 S3 PCB. It is smaller, stealthier and a great soldering project. The function of both is identical. They run the same firmware made by Spacehoon, and they can use the same Ducky scripts. Links to download the firmware and PCB files are in the description. I will guide you through the process step by step. The pre-compiled firmware has some fun examples in it to get you started. Let me start by showing you what this bad USB can do. I plug the ESP in the target computer. Now the bad USB will tell the target computer, no worries, I am just a keyboard. After it is plugged in, it will create a Wi-Fi hotspot, Wifi Duck, to which you can connect from any computer or smartphone. After you connect it, open a browser and type 192.168.4.1 in the address bar. Now you can remotely inject commands in the target computer via this interface. There are some examples in the code. Let me open the first one, Hello World. Now the Ducky script will run and type automated commands in the target computer. Pretty cool, Because the ESP32 acts like a keyboard, the computer will fully trust what it does. You can remotely open websites and even send emails from the target computer's account. In the editor, you can edit the current script, or you can create a new script by typing the new script's name and press Create. Now let me show you how you can flash the firmware. There are 5 steps to flash the software in your ESP32. First, download the zip file with the bins from my GitHub page. The ESP32 S2 and S3 have different zip files. Unzip the files for your board. Now open the online ESP flash tool. I will leave a link in the description. The tool requires a Chromium-based browser. Now we need to set the ESP32 in programming mode. For the ESP32 S3 custom board, hold the boot button when plugging in the USB to enter programming mode. For the S2, you need to hold the boot button and briefly tap the reset, then release boot. Now click Connect and select your ESP32 in the flash tool. Now we select the bin files. First, the bootloader. This is the start code for the chip. Please make sure you enter the memory address as shown in the file name. Now we add the second file, the partitions. This is the map of all code sections for the chip. Change this to 8. We add the third file, the firmware, 10,000. This is the main software program. And finally, we add the spiffs. 3D. This is the memory where all the Ducky scripts are stored. Now click Program. Programming is finished. Now it's best to plug and unplug the USB to restart your ESP32. Your bad USB is ready. Now let's try it out. Plug in the target computer. Connect to Wifi Duck. and type 192.168.4.1 in a browser. And we are in the Wi-Fi Duck interface. Now let's try the talking computer example.
Warning, hardware from the design graveyard detected.
Great, that works. Now let me show you how to assemble the ESP32 S3 custom PCB. First, download the project zip file from my GitHub page. Inside, you will find all files you need to order the PCBs, and the bin files and this assembly instruction. Use the zip file called ESP32 S3 USB PCB Gerber.zip to order the PCBs. You can check the Gerber zip file at gerblook.org. All resistors and capacitors are 0805 size. U2 is a standard AMS 1117 3.3 volt regulator, and the module is an ESP32 S3 W-room 1 and 4. D1 is an 0805 SMD LED. The button SW1 is the same as used on an Arduino Nano. Just search by 3x6x2.5mm tactile switch SMD. I first mount the ESP32 module. Only 8 pins are used in the circuit. You can use a normal soldering iron to connect those to the PCB. Later, you can solder more pins for mechanical stability if you want. After we finish that, we go to the components on the other side, which are much easier to mount. For a snug USB fit, the total thickness should be 2 to 2.2 mm. I used a standard 1.6 mm PCB and glued a thin plastic spacer cut from a bottle underneath. If you have a better idea, please let me know in the comments. Now you can flash the S3 bin files and your Wi-Fi Ducky is ready. I hope you liked the video. If it was useful for you, please like and subscribe, and leave your experiences in the comments.